Hello and welcome to the second chapter in the C1 maths book. This is the Edexcel A-level maths book. It's going to be on chapter 2, which is on quadratic functions, about how to graph them, how to plot them, work out discriminants, work out working with basic graphing and stuff. You'll see what I mean. Most of this work is better done on squared paper or graphical paper, which you'll find in like an ordinary maths book. So yeah, let's get into this. So firstly, the general formula for a quadratic equation is y equals ax squared plus bx plus c. Now what these stand for is a is a real number coefficient like 1 or half, same with b, and same with c. However, it's not really a coefficient, it's just a thing. It's just whatever, a real number. And then this is the y coordinate, and this is like the general formula. So you could say that 2x squared plus 3x plus 10, that is 10, that is a quadratic formula. Oh yeah, a can't equal 0, because then you're just not working with a quadratic formula anymore, because you need the x squared to make it quadratic. A quadratic generally, the most basic ones generally look like this. Well, the most basic, which is y equals x squared, will look roughly like this. Excuse the bad drawing. That, like, it should be 0 0 here. That point should be 0 0. And then if you follow along, it'll be like 1 squared equals y. So if x is 1, y is going to be 1, and that's going to be on both, because remember, when you square minus, it goes positive. That's why it does that. So if x was 2, y would be 2 squared, which is 4, and then as you see, it starts to get bigger and bigger and bigger and gets out of hand very fast. But yeah, that's the main gist of it. So let's head in straight to the questions for 2a. I'm just going to go ahead and do 6. So it says we got to do the values from -4 to 4 and then just graph it. I'm not going to do much graphing because it's not too, but I'll do it anyway. So best way to start off with these type of questions is you make a box like this, and then you just put in your x coordinates, so the range it gives you, so -4, -3, -2, -1, 0, 1, 2, 3, 4. So we're working with a lot of values here. But anyway, now all you got to do is you just got to plug these into the equations which it has given us. I'll write it down if you don't have the book, which is y equals, we're going for, you know what, let's do 8 instead. X, actually no, let's continue doing 6 just in case anyone who does have the book's been doing it. X squared plus 3x plus 2 there, and now we just plug in. So -4 squared plus 3 times -4, so that's basically a minus plus 2. So well, I'll only write this one out. So -4 squared, because if minus squared turned to positive 16, this goes -12, and you got plus 2. Easy way, simplifying, you add the 2, makes it -10. 16 minus 10 means y would equal 6. So we go over here and make that 6. I'm just going to try and do the rest now very fast. Y should equal 2, 4 minus 6, this would be 0. 1 minus 3 plus 2. Oh wait, oh, I think I've made a unless, nah. So yeah, 4, yeah, we proved that. Minus 3 squared would be 9. Minus 9 plus 2, 2. 4, no, that would be 0. Minus 1, so 1. 3 times minus 1 is 2. Plus 2 would be 0. Okay. 0 squared plus 2, so 2. Wait, no, this actually makes sense. Sorry. I don't know why my brain bugged out. X squared, so 1 plus 3, so 4 plus 2, 6. See, look, there's a quadratic pattern, and this is going to be 2, 4, add 6, 10, 12, 9, and 9, 18, 20, 16, add 12, 32. There. So this should be the main pattern. And now if you were to graph it out, it's going to be very hard for me to do this. What it should look like is between minus 2 and minus 1 here, the graph should cut the x-axis like that. And then another main point which you should just remember is the graph should cut or go through the y-axis at 0, 2. Okay, and then that should be the main structure. So when you're graphing, this little secret, the main 3 points you kind of want to be looking for is the y-intercept and the places where it touches the x-axis. We'll be going over that a lot later, but yeah, that's the main basics of this stuff. So let's go new. Don't save that. Okay, let's go to the next one. We can solve using factorization. So what does it basically want us to do here? Solve the equation, blah blah. Does it want us? Okay. So basically, what it's saying here is we're trying to find the roots. You know how I was talking about how the graph's always cut at some points on the x-axis? So we can find those if they give us an equation like x squared plus x 2x plus 1. I'll do that. And that is by doing the double bracket stuff, double bracket factorization and all that. So what we could do here is we can go 1, 2, 1, 2, and we need to find two things that times together to make 1. That's going to be 1 and 1. Then we got x and x, and then we need to find a way to make 2x out of this, and the way you're going to do that is just by making them plus. And then that should work if you do the calculations by doing blah 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 blah. You should find it should make that. And now we know that the point at which the graph crosses the x-axis equals -1, because how can we say, when it cuts the x-axis, y is always going to equal 0, isn't it? So we technically say this is equal to 0. Now when you times any number like 22 times 0, that is always going to make it 0. So to find the x value when y is 0, you just got to make the brackets equal 0. And here it's -1. And you see we only have one root, unlike that one, meaning this is a quadratic that sits on the x-axis, that should be on it at -1. It sits on it. Yeah, and that's how you work it out. So let's just do 2 questions from the book here. I'm gonna do 20. So it says 2x squared is equal to, oh, hey, don't equal to 8. So what we do here, we make it 2x squared minus 8 equals 0 by just taking it over. Now we got to get it into brackets. So here's our two brackets. You're gonna have a 2x and an x, because you can't have anything else to make 2x squared in these brackets. And we need to find two numbers that times together to make 8, and then we'll cancel out. Those numbers should be minus 2 and 4 plus 4. So if you do the calculations, 2x times x is 2x squared, 2x times minus 2 is minus 4x, then 4 times x is plus 4x, so those x ones cancel out, and then 4 times minus 2 is minus 8. And here we have two brackets. Now we do up here, we make them 0, so if this one was 0, x would have to equal 2, and if this one was 0, x would have to equal minus 2. So on the graph would cut at minus 2 and 2 on the x-axis. So that was question 20 on exercise 2b. Because that was done so fast, I'll do another one. No, let's go right for the hard one, right at the bottom. 26. So this one is 4x squared plus 17x equals 6x minus 2x squared. Now that looks like a lot. However, all we got to do here is we got to be moving them over the brackets, and then it won't look as scary. So we'll move over the 6x. We're gonna get, oh, get out of the way, headphones. We're gonna get 4x squared. Because we're moving it over, it's going to be minus 6x. We're going to get plus 11x equals minus 2x squared. Now we just move over the minus 2x squared. We're going to get 6x squared, because we plus, to get rid of the minus, plus 11x equals 0. Now this is a type of factorization which isn't double bracket. This is one where we find a common factor. As we see here, the common factor in these two is x. So we can take x out, and now we're left with 6x plus 11. Seen how that was done? I saw a common factor in the numbers and I took it out. Say if this was, let's just do this quick over here. This has got nothing to do with the actual question. Say this was 6x squared plus 12x. We can not only take out a factor of x, we can actually take out, because you always try and take out the biggest factor, we can actually take out a factor of 6x and make it x plus 2. So there, that would be the smallest it could get, and probably, as they would say, the most simplified. But yeah, we don't have a 12, so you can't do that. Here, scribble, scribble, scribble. Okay, let's now find out what the roots are. Well, obviously, this would mean to make, because we have to make one of them 0, x is going to equal 0, and this would be 0, and 0 times whatever would end up here, which would be 11. Would be 0. So one of the roots is 0, and the other root is going to be 11 over 6. Because put that in there, 11 over 6, oh no, oopsie, nearly messed up there, minus 11 over 6. Because if you put that in there, 6 times minus 11 over 6 is going to be minus 11. Minus 11 plus 11 is 0. So our two roots, if we were to draw it out, would be 0 and minus 11 over 6, which is around 2-ish. So yeah, kind of like that. Yeah, with that being minus 11 over 6, 0, and that being the point of origin, which is 0, 0. That arrow is terrible. Should be like there. Okay, so that's just how you find the roots. Now, what does it want us to do here? You can write quadratic expressions in the form by completing the square. Okay. We now being taught to complete the square. I'm not too fond of this, but I will try. I will try with this. So, let's say let's go over the example they've given us. So we've got x squared plus 8. Oh, geez, 8x here. Okay, so what this is saying, when you complete the square for this, what you do is you basically, what could you say? Half, you could, how, well, I don't know how to put it into words of what you do, but it goes to that. So you would keep the square. Okay, so imagine it goes to that. Oh yes, I should put that here, which is 4 squared. Okay, it'll be better to explain if this was equal, if we put the equal to 0 here. So imagine this is a double bracket, because x plus 4 squared is just this, x plus 4, that's x plus 4 squared. Imagine we've said this is equal to 0, and now we want to put it back in to brackets like this. We could say that half the coefficient here plus like just the x squared minus whatever the coefficient squared is would be equal to this. That was a lot of words, and probably I've complicated things. Let's just, you know what, I will not try to explain it that much, and I'm just going to go through them. So as you know, this would just turn into minus 16, and then you've just completed the square. Oh sorry, got terrible what's the word? You got acid in your throat. Heartburn. There you go. I got heartburn. It's not very good. So let's just go for it. I want to go completely new page because I wrote that pretty big. Don't save. Let's just complete the square for x squared minus minus 16x. These headphones keep getting in my way. And you can basically say that's equal to 0. That's a good way of like getting through it, because be careful though, not every case is going to be like that, I don't think. So yeah, as we do, we just follow the rule. X minus 8 squared minus 8 squared equals 0. And that should be the correct answer. I'm going to check my answers for this because I'm not too confident at this stuff. Okay, where does 2C start? 2C. Here you go. What question was that again? I'm just marking the answer page. Oh, but as I've marked the answer page, I've lost the page that the questions were on. Clever, Robbie. Okay, here you go. What was it? Question 3 on 2C. Oh, I should have said that earlier. Sorry, guys. So yeah, yep, that's right. Ding. Minus 64, because that's what 8 squared is. Let's just go ahead and do 6n, because this introduces a new factor. You got 2x squared plus 16. Oh no, we've got a coefficient to the x squared. What we do here is we take the 2 out. We take the 2 out, and we use these type of brackets, and now we just do the whole bracket thing. So we'll end up with, if we just look at it like this, so let's draw a line. If we just look at it as x squared plus 16x, to get plus 8 squared minus 8 squared. And now you see we've got the 2 out on the outside, so it would end up as 2x plus 8 squared minus 2 times 8 squared, which is 64 times 228, equals 0. And I believe that should be our final answer. What is this? Question 2C6. Uh-oh, I have made a huge mistake. That is not the right answer. Oh no. Oh no. I am a bad teacher. Oh no. Okay, you know what? Let's do some learning together. I found an example which is got a coefficient, and we're going to go through it. So, it says here we're going to be working with 2x squared minus 10x. Okay, so here the coefficient of x squared is 2. So yeah, we still take it out. We take it out here, and we just do the bracket, which is x squared. Oh, we just take it out. Okay, we're just taking it out of a bracket, so it's just like, okay, 2x squared minus 5x, and that's technically the same. Okay, now we complete the square with this. Now we complete the square with this, which is x minus 5 over 2 squared minus 5 over 2 squared, and then there's a 2 outside. And what we can do to say the final answer, you just put the 2 in front of the bracket, x minus 5 over 2 squared minus 5 over 2 squared be 25 over 4 times by 2, 50 over 4, 50 over 4, 25 over 2. It's minus 25 over 2. There we go. And that is, yeah, that is right. So, now that we've learnt how to properly do it with the coefficient via the book, which is a better teacher than me, come on. There we go. Let's do that question again. So 2x squared plus 16x. So as we remember, take it outside bracket, 2x squared, so 2 outside, x squared plus 8x. No. Yes. Now we complete the square with that, so 2 outside the entire bracket, x plus 4 squared minus 4 squared, and that's that. And then we just finish it off. 2 plus 4 squared minus 32. And that is the answer I remember seeing. So yeah, that's how you do it. Very simple. I just have a bad memory for it. I think it was because we've taught it in 2 different ways. Well, to seal the deal, let's go for the hardest one. So let's go for 12, which is 3x squared minus x. Minus x. So take out the 3, 3x squared minus, you're going to have a 1 over 3x. Complete the square with that. So let's go 3 in the big bracket. Be x minus that a third halved. What would be a third halved? 2 6. So yeah, 1 6. Okay. 1 6. No, just 1 6 squared minus 1 over 6 squared, which is 1 over 36, and then we times all that by 3, we get 3x minus 1 over 6 squared, 1 over 36, 72, 108, minus 1 over 108. Oh no, I'm an idiot, sorry, not that, sorry, 3 over 36, which is 1 over 12. 1 over 12. So that all looks messy, so final answer should be 3x minus 1 over 6 squared minus 1 over 12. If I'm wrong, I shall be punished by myself. 3x 1 over 6 squared minus 112. Yeah. Ding ding ding. Okay, so yeah, we've learned that together, people. We've learned together. Isn't that brilliant? Okay, so that's completing the square. You can do quadratic equations by completing the square. Okay, this is now just applying that knowledge to the quadratic equations that we went over before with the double brackets and all that. So let's start very simple. So let's complete the square for x squared plus 6x plus 1. And this is, yeah, introducing something new here. So we can basically say, if we complete the square here, we've got x plus 3 squared. We're going to say minus 3 squared plus 1, because we cannot forget about that. Minus, so you would say minus 3 squared is minus 9, plus 1 is minus 8, so the final answer should be x plus 3 squared minus 8. See, that wasn't that hard. All we're doing now is introducing that c as we went over before, just that c. So let's check that. 2d1. Oh, it wants us to find what x is equal to. Wait, why don't you just do double brackets then? Minus x is equal to minus 3 plus or minus 2 root 2. What's going on here? Okay. Okay. Okay, I think, okay, so we could say this is equal to 0. I'm so sorry, I've very badly taught this, but as I said, this is me learning at the same time as you learning. So, oh well. So here we've got x plus 3 squared is equal to 8, and what we've done is we've taken over the 8. So now we just got to find what x is equal to, and you do that by doing double brackets. So remember, that's equal to x plus 3, x plus 3. If we do that quick in our head, it should be x squared plus 6x plus 9 equals 8. I really, I don't know what's going on here. What am I doing? You can solve quadratic equations. Okay, I know, okay. Okay, I see what they've done. Okay, I'm gonna be honest with you guys here. I don't really know what completing the square is doing and achieving, which the double brackets isn't. Which is not very good, because I know the double bracket's very good. I just don't know what completing the square is achieving that double brackets can't. I thought it was something to do with the y coordinate. So what is it doing? Let's go back. Let's find out. You can write quadratic by completing the square. Complete squares. Complete square. Complete the square. Complete the square. Oh, complete the square. Complete the square. X equals, then is this when you can't double brackets it, but then you can use quadratic equation. So I think I know what the reason for this is. Completing the square is a way of doing the quadratic function, the quadratic thing, which is minus, sorry if this is new to you, but if you're going into A level you should know this, b squared minus 4ac over 2a. It's a way of doing that without a calculator, I believe. It is, isn't it? Because you wouldn't be able to solve x squared plus 8. Okay. Very, very sorry about all this. Okay, so I'm just going to do the example. X squared plus 8x plus 10 equals 0. This cannot be double bracket efficiently, which is where they're using real numbers, because 5 and 2, nah. 10 and 1, nah. Yeah, it's not gonna be done efficiently. You're gonna have some very weird, crazy numbers. So what we do is we go x squared plus 8x is equal to minus 10. Then we complete the square. X plus 4 squared minus 4 squared equals minus 10. Then we take over the minus 4 squared, so we go x plus 4 squared is equal to 16 minus 10, which is 6. Then we square root both sides to get x plus 4. Oh, we don't even need the bracket anymore here. X plus 4 is equal to root 6. And now we can move over the 4 to say x is equal to, let's say, root 6 minus 4. Is that what it's saying? Is that what you're saying? Minus 4 minus 6, root 6 minus 4. Yeah, okay. That's what it's saying. Generally, we should be leaving it like this. There. But I like to leave it like that, because then you get rid of 1 minus. Okay. So yeah, that all works, and that is how you would find it, because you could say plus or minus root 6. Oh yeah, silly me. It's the two roots are going to be that or that, because remember, when you square a number, it could be minus or a plus. That's where we're getting that from, because it'd be minus root 6 would turn into positive 6 if you squared it, and positive root 6 squared is also going to equal 6. Oh, pardon me. So this should be your two roots, minus 4 plus root 6 and minus 4 minus root 6. Ah, jeez, this is very complicated for me, trying to teach, and this, oh well, hope you're enjoying the ride. You probably know more about this than me now for the amount of time I've taken learning this. Okay, let's go over it. 2x squared plus, oh no, we're doing the old ones. Oh, Robbie. Your brain is not here today, is it? Okay, we're going over this one. X squared plus 6x plus 1 equals 0. So, let's do it real quick. X squared plus 6x equals minus 1. X plus 3 squared minus 3 squared equals minus 1. X plus 3 squared is equal to minus 1 plus that, which is 8, which is where we were before. Square root the whole thing. X plus 3 equals root 8. Simples down to, if we remember surd, simples down to 2 root 2. Yeah, 2 root 2, because root 4 is 2. Yep. Then you say x is equal to, oh yeah, let's put the plus and minus in there. Remember, so x is equal to 3 plus root 8, or x is equal to 3 minus root 8. And yeah, that should be the right answer. Let's go check. Where are these answers for 2D1? Minus 3 what? Okay, so minus 3 because you're moving over a positive 3, it turns into a minus. Minus 3 plus or minus root 8, which is 2 root 2. Okay, those are right. Let's move on to the next ones. I am really far behind. I'm doing this terrible. Okay, x squared plus 4x minus 2 equals 0. So what we do here, we go x squared plus 4x equals 2, moved over the 2. We go x plus 2 squared minus 2 squared equals 2. We've completed the square. We then go x plus 2 squared equals 2 plus 2 squared, which is 4, is that, which is equal to 6. So yeah, because that, you move that over. Then you square root everything. So x plus 2 is equal to root 6, which is, nope, you can't simplify that, root 6. Then you go x is equal to minus 2 plus or minus root 6. And yep, so your 2 roots, and that should be the answer. Let us see, shall we? Let us see. What question was this? Question 4? Question 4. 2D. Ah, okay. That is the right answer. Okay, I think I'm starting to get on track with this stuff now. New. That's it. Okay. Let's do. I say we go straight for 10 then. We go 5x squared plus 8x minus 2 equals 0. So what we do, we go 5x squared plus 8x equals 2. Remember, now we've got the coefficient, we turn it into x squared plus 8 over 5x equals 2. Now we say 5 bigger bracket, smaller bracket, x plus half of that, which is 4 over 5, squared minus 4 over 5 squared equals 2. We've got to times this all by 5, so 5x plus 4 over 5 squared minus, so this squared would be 16 over 25. 16 times 5 is 80, so you'd say minus 80 over 25. Could be simplified down to how many times does 5 go into that? 16, so 16 over 5 is, yeah, so minus 16 over 5 is equal to 2. We take over the 16 over 5, so we say 5x plus 4 over 5 squared equals 2 plus 16 over 5, which is 10, which is 26 over 5. So let's move up here now. 5x plus 4 over 5 squared equals 26 over 5. Now we divide both sides by 5. You would get x plus 4 over 5 squared equals 26 over 5 divided by 5 is 26 over 25, I believe. Do I have my calculator near me? Oh wait, I'm not supposed to use it. Okay, so yeah, that should be right. Let's just go on a limb. Let's believe in myself. Let's now, we have to square root both sides, so x plus 4 over 5 equals this square rooted, which is root 26 over 5. Root 26 over 5. We then have to bring that over, so x, so you would get the x, and then you would say x is equal to root 26, oh well, yeah, plus or minus root 26 over 5 minus 4 over 5. So our x value should be, due to the same denominator, oh Jesus, our x value should be, due to their same denominators, minus 4 plus or minus root 26 over 5. Let's see if root 26 can be simplified. 4, no. 9, 17, no. 6, no. No. So, oh, no. 4, 9. Yeah, so 4, 9, 16. No, okay, none of them going. So, that should be our final answer for x. Sorry if that seemed like a haze of numbers. I just had to quickly go through that. Exercise 2D. X equals minus 4 over 5 plus or minus root 26 over 5, which can be simplified to that. Whew! So yeah, that is completing the square using the quadratic stuff. I don't know if I should split the video into 2, or should I keep going? Ah, nah, there's only a few more pages. Let's keep going. Now it's, oh, what? Oh, come on. Now it's teaching us the quadratic equation. It's like, that's like giving us like a really terrible dinner and then like saying, actually no, that's terrible. I don't even know, I'm just annoyed. Like, why are you going to teach us that if you're then going to teach us quadratic equation? What? Why? Why? Oh, jeez. Okay, let's do quadratic equation then. What? So that was a quadratic equation. I know this. Plus or minus b squared minus 4ac. This is all rooted, by the way, over 2a, where remember a squared plus bx plus c. So, and then you just put the desired things in the desired places. Okay, and that seems to all works out. So now let's work some out using quadratic equations. So this stuff is just because I don't have a calculator, and you're not supposed to have a calculator for C1. We technically shouldn't be working these out. However, we should know how to substitute in. So we go 5x squared. This is from exercise 2e question 8. 5x squared plus 4x minus 3 equals 0. So we just take what we can and we just plug it in here. So here's the b, so minus 4, because it's a positive 4, plus or minus root, so 4 squared, 16, minus 4 times a, which is the 5, times c, which is the minus 3, over 2 of a, which is 10. So this would end up being minus 20 plus 20. This would end up being root 36. And you do minus 4 plus or minus. So minus 4 plus or minus root 36 over 10. And that should be your thing. Don't know why we've been taught completing the square method if this easily tells us it just that fast. It's a lot faster, in my opinion, doing that. Maybe completing squares a lot faster for you, I don't know. But yeah, that was very easy. Okay, I'm just going to move straight on because I think we get it. That quadratic equation, just need to substitute in, ever since we are not allowed to use calculator in C1. Here, this is, okay, this is using discriminant, I'm guessing. So this is telling you whether what the shape of the parabola will be, if it's a, as I like to say, if it's a U or an N. So the A in front of the ax squared, so this A, this decides the shape, and that is by if A is positive or negative. If A, this is how it says in the book, if A is bigger than 0, which meaning it's positive, it will be the commonly known U shape. That's more commonly known using quadratics. However, if A is smaller than 0, meaning it's negative, it's going to be the N shape, like that. So that is how you decide on the shape that it's going to be. Now you can take it a step further to decide whether it's going to have roots, and that is by using the b squared and the 4ac from the quadratic equation. So if we have three things here, b squared is bigger than 4ac, we will know that the parabola will have 2 points of intersection on the x-axis, or 2 roots. If b squared is equal to 4ac, we will know that it has 1 root on the x-axis, so basically where it's sitting on it. Then if we know if b squared is smaller than 4ac, we will know that the parabola doesn't even touch the x-axis. And then here's something, because these are all U's, the a in all of these cases is going to be bigger than 0. Just a little reminder. But yeah, so b squared bigger than 4ac, you're going to have 2 roots. B squared equal to 4ac, you're going to have 1 root. B squared smaller than 4ac, you're going to have no roots. Okay? Three things here and the 2 thing there. Basically 5 rules, but I like to categorize them. So it's like doing a check. So check your A, then check your B. I mean, it's called this is called the discriminant. That b squared blah blah blah. So if your discriminant is bigger than whatever, but I remember in my head as check your A's before you check your B's. That's something. You don't have to check it in that order. It's just that one little phrase links all that to stuff. So let's go over it. Sketch the graphs using the following equations. So we know that y, so let's do one, y equals x squared plus 3x plus 2. So let's check the A. If there's nothing there, always remember it's basically a 1. So it fulfills A is bigger than 0, so we're going to have a U. Then if we take like the b squared and the 4ac, so b squared, here's our b, 9, 4 times a is going to be 1, so 4 times c, 2, 8, 9 is bigger than 8, meaning we're going to have 2 roots. So roughly it's going to be like that. And then now that we know those two things, we could then go on to do double brackets to find the actual roots. And the actual roots are going to be plus 2 plus 1. And that means x crosses there and x crosses there. Ooh, minus 1. Yeah, and that all works out. So that's also, we checked our A, showed it was a U, checked our discriminant, showed 2 roots, and then we found the 2 roots. Here we go. The discriminant is, in a way, these things you could say aren't that useful. However, you can come across in tests stuff like b squared. It will say b squared is bigger than 4ac. How many roots will the quadratic function have, or whatever? And you would have to say 2. You could complain they're not useful, but I would remember them. It also just means you have a general better understanding of quadratics in the end anyway. So let's go right onto the mixed exercises and wrap this up. So let's see, let's not draw some graphs because I've got no paper. Let's solve the following equations. So we've got y squared equals, no, let's make a new one. Silly me, don't save. We've got y squared plus 3y plus 2 equals 0. Now don't be fooled here, this isn't the y coordinate. Well, I don't think it is, but we could still do double brackets just because it's not an x. It's just an algebraic letter. We could still do double brackets. We could still do this. We could say plus 2y plus 1 equals 0, and we just then say y equals minus 2. Oh, look at that, it's the same as the one we just did, minus 1. And we can just say that. This y could be t, it could be w, it could be o, it could be l. This can still work no matter what letters here. It's just a placeholder. So let's do that was 2a. Let's do 2d. So 2x minus 5 squared equals 7. We notice this is in one of the later stages of completing the square. So what we can just do here is we go 2x minus 5 equals root 7. Then we say 2x equals root 7. Oh yeah, plus or minus root 7. Minus 5. Then we go x is equal to minus 5 plus or minus root 7 over 2. And that should be our answer. Let me check that, because as you know, I was not too good at completing the square. 2D, 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 2D on 2G, 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 2D on 2G. Yep, that is correct, Amondo. Okay, sweet beans. Let's go on to, now, we're not doing any which is drawing graphs, unless I think there is some value in them. Solve the following equations using the formula. Okay, I like these. So this is 3, and we're going to do I and II, and that's basically complete the square and using the formula, which is the quadratic formula. Let's do it for C. We're only going to do C here. So we complete the square. 5x squared plus 3x minus 1 equals 0. Remember, we're going to move over the minus 1, so it will be equal to 1. Then we take out the 5. We're going to get 5x squared plus 3 over 5x equals 1. Now we complete the square with what's in here. X plus half of that is, we're going to have to double it, 6 over 10, 3 over 10. 3 over 10 squared minus 3 over 10 squared equals 1. Oh yeah, big bracket there. Times all that by 5. 5x plus 3, 10 squared minus, times that by 5, you'd get 15 over 10 squared. Oh wait, no, we have to square this first. You cannot do that. So 9 over 100 times by 5, 45 over 100. 45 over 100, which would be 9 over 20. Yep, 9 over 20. Is equal to 1. And then I think if they are saying complete the square, we are actually gonna look to make the answer equal to 0. So we would say minus 9 over 20 minus 1, so it should become minus 29 over 20 equals 0. And let me check. 2G 3C. Okay, nah. We should have left it in the, we do need to make it where x is equal to something. So we just revert what we did here and we take it over, so we'll have 5x plus 3 over 10 squared. We take over the minus 920 is equal to 1 plus 9 over 20. So you would get positive 29 over 20. So that would be 29 over 20. Okay. We divide that side by 5, so it would get x plus 3 over 10 squared is equal to, divide by 5. When you divide a number like this by 5, you basically times the denominator by 5, so you would get 29 over 100, right? Yeah. Then square the sides, plus 3 over 10 equals root 29 over 10, because 100 squared is 10. We then take over 3 over 10. X is equal to plus or minus root 29 over 10 minus 3 over 10. That can be simplified down to x equals, can that be a third? 4, no. 9, no. Okay, it can't be. Minus 3 plus or minus root 29 over 10. And if I remember correctly from seeing the answer, that should be the answer. And indeed it is. And as it said, it wants to sub into the formula, which is a much faster way in my opinion. If we just look back up here. Oh jeez, okay, pen's being a bit weird. Yeah, if we just look back up here, we take the b, which is 3, we get minus 3 because it's a positive, plus minus. Oh, oopsie, that's a very bendy root. You get 3 squared 9, minus 4, 5, minus 1, because the 5 in front of the x squared and minus 1 at the end, over 2 of 5, which is 10. Oh, look at this. This is going to simplify down to 29, ain't it? Because this turns into plus 20. So look at that. Much faster, much simpler. Root 29 over 10. And look at that. Same, whoa, same answer, but this was so much faster. Completing the square, I don't understand why we need to know. Okay, let's go to new question. Let's see here. Find, okay, this looks cool. Question 6. Find as surds the roots to the equation 2x plus 1 x minus 4 minus x minus 2 squared equals 0. This is a lot. Ooh, this is a lot. Unfortunately, we cannot like substitute in x's because it wouldn't end up the same. However, what I think we should start, what we should do, so we should just go ahead and do this. Equals x minus 2 squared, and basically work it out as completing the square because it's put in the formula, so it's much easier to work out as complete the square. So you take the 2 out of that. Oh my god, you take the 2 out of that. Okay, you know what, square doing, forget doing it like this. Let's just expand our brackets. 2x squared minus 3x minus 4 minus x squared minus 4x plus 4 equals 0. We're going to end up with 2x squared minus 6x minus 8 equals, oh no, well yeah, would equal x squared minus 4x plus 4, because we've moved this over to where the 0 was. Now we can just start moving things over. X squared, you'd get x squared there. We move that over so it becomes positive, so we add on minus 2x. Move that over, minus 12 equals 0. Now it wants us to find the roots, and we should leave it as surds. So I'm just going to take the quick root, use a quadratic equation to help you. Remember, let's just do this, a, and we'll put a 1 here. So, because, oh yeah, now this is our first thing, because it's minus b in the quadratic equation, plus or minus b squared minus 4ac over 2a, because it's minus b, because b is minus 2, the minuses cancel out, it becomes 2, plus or minus minus 2 squared, 4 minus 4a, which is 1, c, which is minus 12. So it would end up with plus 4 times 12, which is it 48? Yeah, it's 48. So 4 plus 48, 52 over 2. So 2 plus or minus root 52 over 2. We could possibly, can we get out of this bracket? Yeah, we can. 4 goes, does 16, 16, 32, 48, no. 27, no, 25, no. And then, yeah, okay. So 4 goes into that. So if we would put that in third form, it'll be 2. Does 4 go into that? Yeah, it does. 2 root 2 root 40 add 12, so that would be 43. So no, yeah, so 13. 2 root 13 over 2, so 2 plus or minus root 2 over that. We can split this fraction into 2 over 2 plus or minus 2 root 13 over 2, because they have the same, this is something you can, same denominator, you can do this. 2 over 2 is 1, so 1 plus this, which is, these cancel out, so it's 1 plus or minus root 13, I believe. 1 plus root 13. What question was this? 6. Yeah, 1 plus or minus root 13. There you go. And that's your final answer. That seemed very complicated. So let's go over again. We just subbed in what we got from this. Because, okay, so screw what we did. That was unimportant. We just expanded out the brackets to get this. Moved over to get that. Put this into the quadratic formula up here. Then we simplified down from what we know, and we simplified down to that using splitting fractions. Okay, one last question. Oh wait, no. Okay, one last question, and it's going to be the hardest question in the mix exercises. Question 7. Use algebra to solve x minus 1 x plus 2 equals, oh geez, what am I doing, equals 18. Well, what do you mean use algebra? Can we just I don't know. I'm guessing solving it, they just want to find 2 values for x. So what I would do is I would just expand out these brackets. You would get 2, no, x squared plus x minus 2 equals 18. Put the 18 over there. X squared plus x minus 20 equals 0. 5 and 4. So x yeah, plus 5, oh jeez, plus 5 x minus 4 equals 0. X equals minus 5, x equals 4. And yeah, that would, you could solve it like that. I think just ignore what they mean by algebra. Let me check that if that's the final answer. Yeah, no. Yeah, they basically just mean do this. So yeah, that was a lot easier than 6. That was a lot easier. Don't know why that was number 7. But yeah, there you go. And that's that. Boom, boom, boom. Maybe it's a bit confusing because of that. But yeah, that's the end of that then. The end of chapter 2. Whew, that was very very tiring for me, because I did not know completing the squares. I thought I did. I thought I knew it, but I didn't. And then I got very annoyed because it basically proved that it was not that useful against the quadratic formula. There must be a useful thing for it though, I think, to find the minimum point. But then that's just x. Oh wait. Oh wait. Oh wait. I think I just realized there is one use for it. The use for completing the square is for when b, so let's go over, remember this, when b squared is smaller than 4ac, there is going to be no roots in the parabola. Now this creates very bad, the reason why we can't use the quadratic formula to work out what the x is here, so like the minimum point of x, is because the root would end up being less than 0, and you can't have a root minus number. Well, that starts going into complex stuff that we do not need to know at this point. So what would end up happening is we complete the square and we will find the lowest point. So say we had 5x squared plus 2x plus 10. I have no idea what here, so yeah, because that would make 4ac definitely higher than that. So we'd say that's equal to 0. We cannot do anything with this. This would get too hard. So we complete the square. We move that. Okay, so let's start by moving over the 10. X squared plus 2x equals minus 10. Now let's take out the 5. 5x squared plus 2 over 5x equals minus 10. Now let's complete the square. 5x plus 1 over 5x squared. Oh, no, silly me, don't leave that there. Squared minus 1 over 5 squared equals minus 10. Okay, let's now work out that. So this squared 1 over 25 times by 5, 1 over 125, so 5x plus 1 over 5 squared minus 1 over 125 equals minus 10. Just realized an error there. Minus 10. And then we move things over. So 5x plus 1 over 5 squared equals 10 over 1. Oh geez, I've created something very hard for myself. This is the extra challenge. So we got, okay, so let's just keep it as 10 over 1, 1 over 125 minus 10 over 1. We got to times this by 125, which is 1250. So we've got 100. Okay, so we're gonna get minus. Whoa. Okay, so we're gonna get minus 1249 over 125. Jesus Christ, what is that? That is disgusting. Then divided by 5x plus 1 over 5 squared equals, times this by 5, 125 split in half is 750, right? No, it isn't, you ding dong. 500, 625, right? Yep. So we would get 1249 over 625. Then we square this we square them, so x plus that equals root 1249 over root 625. Okay, let's see if we can remember that, because we're gonna have to make some more space. Okay, no, that'll take way too long. Root 1249 root 625. Root 1249 625. 1249 625. 1249 625 x plus 1/5. Okay, so root 1249 over root 625 is equal to that minus a fifth. Okay, so we're just gonna leave it as x will equal root 1249 over root 625 minus 1/5 equals that, and it's plus or minus, yeah, and that, whoo, that's a lot of stuff. That is a lot of stuff. That is a lot of stuff. So wow. That, oh, okay. Am I going crazy, or am I just... I think I've created that shape. Because you could have 4 roots, couldn't you? You could have... oh jeez. You could have... ooh, you could have plus root 125 over minus that. You could have minus 1 over plus that. Oh jeez. Ah jeez, what have I done? What have I done? One's over do a triangle. Woo! Okay, no. We could okay. Well, yeah. General gist, there's an actual thing for completing the square, which is it will help you find the minimum point when a parabola is like that. That is terrible. That is shocking. Like that. Okay, I'm done. I'm tired now. I never knew this tool existed. What? Whoa. Oh my god. That is actually very cool. Could I write my name like this? Oh god, no, wait. Stop it. Okay. Great. Okay. Oh. Okay, screw it. Yeah, well, that's been chapter 2. That's been great. I need to end it, and thanks for watching.